Hi everyone, welcome to today's tutorial. Today we're going to talk about Faraday's first law of electrolysis. So Faraday's first law of electrolysis states that the mass of an element deposited during electrolysis is directly proportional to the quantity of electricity passed through it. So this is Faraday's first law of electrolysis. So this law, we can interpret this law with a mathematical expression. Mass is directly proportional to quantity. So M stands for mass, whereas Q stands for quantity of electricity passed through electrolyte. So quantity of electricity given by IT, which is current times time. Going back to the expression, we can write M varies as IT, since quantity is defined as the product of current and time. Okay? Having done that, we can still put this expression, turn it to an equation by introducing a quantity sign and a constant, which you can call or term as Z. The constant Z is known as the electrochemical equivalent of the substance deposited during electrolysis. So these are equations in the equation of Faraday's first law. Mass equal to ZQ, or we can write mass equal to ZIT, since quantity is current times time. Okay? You will take a plot of mass of substance deposited against quantity of electricity passed through electrolyte. We're going to get a straight line graph to prove Faraday's first law of electrolysis. If we take the slope, or what we call the gradient of this graph, take this place as M1, M2. The change in vertical axis, that from here to here, can be written as delta M, change in mass. Take this place as Q2, Q1. Change in horizontal axis can be given as Q2 minus Q1, that is delta Q. Looking at this equation and this graph, the slope of Faraday's first law graph can be given as change in vertical axis all over change in horizontal axis. So what is this slope equivalent to? The slope of the gradient of Faraday's first law is equivalent to Z, which is the electrochemical equivalent. Then remember that M from Faraday's first law, M equal to ZQ. So if I make Z the subject, Z becomes M over Q, which is what we have over here. So the slope of the Faraday's first law represents the electrochemical equivalent of the deposited substance. So having understood the Faraday's first law and the mathematical interpretation, we now look at the calculation involving Faraday's first law. In this tutorial, we are going to start working with balanced chemical equation. We want to get a formula that can take care of writing of balanced equation to solve Faraday's first law. To go back to the first law, M equal to ZQ. Z is the electrochemical equivalent of the element. This Z defined by using AM all over C times F. So the electrochemical equivalent given by the atomic mass, this is the relative atomic mass of the element. This is the Faraday constant, 96500, the constant, while this is the charge of the metal. So we can get make a equation of metal by dividing the relative atomic mass of the metal by the product of the charge and the Faraday constant. So since Z is AM all over C times F, we now put this into this equation. We now have M replacing Z with this, we have AM all over times Q, that is C times F. So if I should substitute the value of Z here with this expression, I will have this equation. So with this equation, we can tackle problems on Faraday first without going to write chemical equation. If I divide both sides by the atomic mass, if I divide both sides by the atomic mass, I now have M over AM equal to Q C times F. So this formula can be used to solve problems of Faraday's first law. From here, we can find the mass of the element deposited, can find atomic mass, we can find the charge or the valence of the element, and Q, we can find the current and time in Q. So having done this, so that is the simplified formula for solving problems of Faraday's first law. Now, let us take a problem and then see how we can apply this formula. We have calculate the mass of copper deposited in the electrolysis of aqueous copper sulfate using current of 5 amperes for 1 hour. Okay? Then we're given CU, the relative mass of copper as 64 approximately, then 1 Faraday as 96500 coulombs. So how do we solve this problem? So recall the formula M over AM equal to QC times F. We try to make M the solve the formula. Since we're looking for mass, our mass becomes Q times AM all over C times F. So having done that, we now read the values we need. In Q is IT. Shouldn't forget that. Our current here is 5 amperes, given the equation. Our time is 1 hour, and time should be given in seconds. 1 hour is 3,600 seconds. So we move up. So get our Q. Q is IT, which is 5 times 3,600. That gives us 18,000 columns. Unit of what is columns. Going to this formula, okay, remember we have atomic mass of copper given to us as 64. Then the charge of copper. How do we know the charge of copper? The substance is copper sulfate given to us. Copper sulfate can ionize, give us copper 2 ion and SO4 ion. So the charge on copper is +2 over here. So having done that, we now substitute in this formula. Mass equal to Q is given as 18,000. Atomic mass of copper is 64. Then all over C is 2, valence of copper, and then 96500. With that, we can get the answer 18,000 times 64 divided by 2 divided by 96500. The mass of copper deposited is 5.97 grams approximately. So if you apply the chemical equation method, you still get the same answer. So the second problem we want to take now is see on Faraday's first law to demonstrate how to apply this formula. So it's calculate the time taken, time in minutes taken to deposit 2.7 grams of aluminium in electrolysis of aluminium chloride aqueous using 10 amperes of current. And then we are giving the atoms of aluminium as 27, 1 Faraday as 96500 coulomb. So how do we solve this problem? We second list what we have. Mass of aluminium is 2.7 grams. Current used is 10 amperes. And we're looking for time. Then also, we'll need to get the valency or the charge of aluminium. The salt used is aluminum chloride. When ionized in water, gives off aluminum triion and chloride ion. So the charge on aluminium is +3. So having done that, we'll now go to the formula M all over AM Q all over C times F. But we know that Q is current times time. So we can play this Q with current times time. We can go ahead and make time the subject without wasting time. Time becomes equal to M times C times F all over atomic mass times current. We then substitute in this formula and then get our time. A very simple formula, a simple method of getting your answer as fast as possible. For those who write multiple choice questions or little questions, without wasting time, can get your answer without for the reverse step of writing chemical equation. So D becomes mass 2.7, charge 3, 96500 all over 27 atomic mass, then current is 10. If we solve this problem, we will have 96500 divided by 270. So our time becomes 2895 seconds. So the time should be kept in the SI unit. But the question says that we should get the time in minutes. I will know that 60 seconds make a minute. Since the question emphasizes that the time should be in minutes. In your working, you get time in seconds, then you convert it to minutes by dividing by 60. So divide by 60, we now have 48.25 minutes as the time of electrolysis. So that is example number 2. The third example says 0.222 grams of a divalent metal was deposited when a current of 0.45 amperes was passed through its salt for 25 minutes. Calculate the relative atomic mass of the metal. Take 1 Faraday as 96500 coulomb. So we'll have a look at this problem again. On Faraday first law, the mass of the metal is 0.222 grams. Then we don't know the name of the metal hidden from us. Or we don't know the name of the salt. So, but we are told from this we have a clue that the metal is divalent, that is, has valency of 2 or charge of +2. Then the current uses 0.45 amperes. Time is 25 minutes, which we convert to seconds. Multiply by 60. 60 seconds make a minute. That gives us 1,500 seconds. Now, remember our equation that says mass over atomic mass, Q C times F. Of course, we can get our Q here, or we can substitute and put IT here and work straight, or multiply I and T to get our Q. So we're looking for the atomic mass. AM becomes mass times C times F all over IT, all over Q, as the case may be. So solving this, we have our mass is 0.222, the charge is 2, Faraday constant is that, then current is 0.45, and time is 1,500 seconds. So solving this, we're going to have divided by 0.45 divided by 1,500. We have 63.5 approximately at the relative atomic mass of the metal, which likely is copper. From the value of the relative amount of copper is around 63.5. So the unknown metal should be copper. So having done that, we take one more example on Faraday's first law. I'll say that calculate the number of moles of silver deposited when 10 farad of electricity is passed through silver nitrate. So from Faraday's the equation we have this. So we make N, this is set as number of moles, mass over atomic mass, equal to Q C times F. The value of our Q is 10 farad. The charge of silver is 1 times F. F cancels F. We now have 10 moles of silver obtained. So thank you for listening to today's tutorial. Keep on watching and always subscribe to our channel, which is Best Science Brain. Follow us on YouTube and subscribe to our channel, Best Science Brain. Thank you for listening. Have a nice day.